In this exam question, we are going to look at question 3 on the winter 2011 question paper 41. And it says this: three coplanar forces of magnitudes 15 Newton, 12 Newton, and 12 Newton again, act at a point A in directions as shown in the diagram. Find a component of the resultant of the three forces in the direction of AB and perpendicular to AB. So this question is telling you where the referential is. You cannot pick your own. Otherwise, you will probably pick here this one as being the x-axis and this one as being the y-axis, because these two make a 90-degree angle, meaning that you would have to decompose only the 12 Newton force. But they tell you what the referential is, so that's what you have to work with. Okay, so here you have it. 40 degrees is the angle that each one of these 12 Newton force make with this direction AB, which is now going to be your x-axis. And 50 degrees is the one that it makes with the vertical. Let me see again. I know you know that this is 90 degrees. Okay. You know that this bit over here is 90 degrees, right? So if this is 40, and if you know that this is 90, you have 90 plus 40, this is 130, meaning that this bit over here is 180 minus 130, which is 50 degrees. Okay, so you already have all the information required to decompose all of the forces. So let's look first at the resultant in the x direction. That's your first question, A. You have 12 Newton force, one in the positive side of the y-axis, the other one in the negative side of the y-axis, but both on the positive side of the x-axis. So the magnitude of their horizontal component is going to be the same and equal to 12 cosine of 40. So that's why you have here 2 times 12 cosine of 40, positive because they point to the right, and I've decided positive to be the right, minus 15 cosine of 50. 15 is the magnitude of this force. I already explained why this angle over here is 50. You are looking at the adjacent of the rectangle triangle, so use the cosine like over there. And here you have it. Just plug this everything in a calculator, and you have 8.34 newtons, correct to three significant figures. All right. I wrote down here in 4 significant figures because I'm going to use this value on the next sub-question. And you don't want to do double rounding, so you use one extra significant figure if you are going to plug in the value that you calculate in a further calculation. In the y-axis, what you have the vertical component of the 15 Newton force, which is 15 sine of 50. You have the vertical component of this 12 Newton force, which is the 12 sine of 40, both pointing up. Pointing down, you have the vertical component of this 12 Newton force, which is also 12 cosine of 40, now affected by a negative sign because it's pointing down. Obviously, these two are going to cut out, leaving just that bit as the vertical component of the resultant, which is 11.5. To 4 significant figures, it's 11.49. Calculating the resultant, you put these two so that you don't do double rounding. So it's going to be square root of this square plus that squared, and you have a value of 14.4 newtons, correct to 3 significant figures. The angle is going to be tan -1 of the y component divided by the x component, and that's going to be a 52.7 degree angle with the direction AB, or the x-axis in this case. Let's now look at this exam question. This is from spring 2015, question paper 43, question 5. And it says 4 coplanar forces of magnitudes 4 Newton, 8 Newton, and 12 Newton, and 16 Newton act at a point. The directions in which the forces act are shown in the picture. Find the magnitude and direction of the resultant of the 4 forces. So you have 4 forces over here. The first thing that you should do is to pick a referential. And since a referential can be any, it's really up to you. You should pick one that gives you less work in terms of the decomposition of forces. And the first thing that you should look at is that this force appears to be perpendicular to this one. But again, you can never trust the diagram. You have to use the numerical values that you have in the diagram, which are in this case the angles. And since each one of these is 30, if you have 30 times 3, that's 90. So here you have the proof that the 60 Newton force makes a 90-degree angle with a 4 Newton force. If you put here the y-axis and here the x-axis, there's no need to decompose the 16 and the 4 Newton force. You only have to do that for the 8 and the 12 Newton force. All right, so that's what I did already. It's here. It's here. Let me put this smaller. All right. So now that you know that you need to decompose the 12 Newton and the 8 Newton force, I'm going to start with the 12. What is the angle that you have between the x-axis and the 12 Newton force? Is 30 plus 30. This is 60, right? So now that I look at it, I did it another way, just to prove that this is math and you can use SOHCAHTOA the way you want. I could have used, like I was going to say, the 12 times the cosine of 60, 30 plus 30. Instead, what I actually did was 12 sine of 30. If you do 12 sine of 30, what are you going to have? You are going to have this over here. I use instead this rectangle triangle, and I can, there's nothing preventing me from doing. Usually it's always done in the x-axis, but I did this on purpose to show you that this can be done on the y-axis as well. So if you want to get the horizontal component of this 12 Newton force, you can also do it by using this angle with the y-axis. But in this case, you are going to use the sine, because this over here, which is this over here, is the opposite to this angle. Hence, the use of the sine. So 12 sine of 30 plus, and now I used again the x-axis for the 8 Newton force. So I have 8 cosine of 30 over here. On the y-axis, you have what? You have the 16 Newton force. You have now 12 cosine of 30, again, using this angle. Now, this is going to be the adjacent to this triangle, hence the cosine, plus 8 sine of 30. I'm using this angle over here for the 8 Newton force, and the sine tells me that I'm using this side, which is that one over there. Plug everything in the calculator, and you have these two components, the x and the y. I need the magnitude, so this is the square root of this square plus that squared, and that gives a value of 34.8 newtons, correct to 3 significant figures. For the angle, I used what? I'm using the 30 divided by the 16, so I'm using y over x, so I'm calculating the actual angle in relation to the x-axis. So it's tan negative 1 of 30.39 divided by 16.93, which gives the value of 60.9 degrees with the horizontal. That's what this means, W/H with the horizontal. The next question would be, this is not what I want, it's this. The forces of magnitudes 4 Newton and 16 Newton exchange their directions, and the forces of magnitude 8 Newton and 12 Newton also exchange their directions, as you can see over here. So this is flipped over to this side. State the magnitude and direction of the resultant of the 4 forces in picture 2. Changing the position of the relative position of the forces, but keeping the magnitudes and the angles between them the same, would this change the magnitude of the force? Look, this is just a 2-mark question, so there's not much calculation involved over here. This should give you a hint that the angle over here should be emerging from what you calculated in the previous sub-question, right? And obviously, if you flip the position of this, the magnitude of the resultant force should be the same. Okay? What about the direction? If you flip this, the only thing that is going to happen is that the angle that you calculated before is not going to be with the horizontal anymore, it's going to be with the vertical. If you still want to put the angle in relation to the horizontal, then it's 90 minus that, which is 29.1 with the horizontal. Okay, that's why you have 2 marks, 1 for each one of these questions or these answers.